Hello, sir. Hello, friends. Myself, Dr. Bhagwan Singh Doval. Today, we are going to discuss about catalysis. Catalysis is a substance that alters the rate of reaction of a particular chemical reaction. It chemically unchanged at the end of chemical reaction. Catalysis are two types. Positive catalyst, which increase the rate of reaction, and negative catalyst, which is also called as inhibitor, which decrease the rate of reaction. Catalysts are specific in nature. We can say specificity of catalyst. The catalyst is specific in nature. It means by the change of catalyst, nature of the product changes, or specific catalyst for a specific reaction. Characteristics of catalyst. The catalyst remains unchanged in mass and chemical composition. In the reaction, a small quantity of catalyst is required. Means a small quantity of catalyst carries number of reaction. For example, 1 mole of colloid platinum catalyzes number of reactions. The catalyst does not change the equilibrium constant, but the equilibrium approaches earlier. The catalyst cannot make impossible reaction to occur and does not initiate a reaction. Catalyst poisons. There are certain substances which decrease or destroys the activity of the catalyst. Such substances are known as catalytic poisons. Example, arsenic destroys the catalytic activity of the platinum. Here the catalyst is platinum in the manufacturing of sulfuric acid. The catalyst promoter is nothing but these are certain substances which increase the activity of the catalyst. Such substances are known as catalyst promoters. Example, MO acts as promoter in manufacturing of the ammonia by Haber's process. Example, N2 plus S2 in presence of Fe catalyst or MO promoter, it gives twice NH3. The catalyst exhibits maximum activity at a particular temperature, which is known as optimum temperature. By using catalyst, the activation energy of the reaction get decreased. We have presented here in the graph. It shows potential energy versus reaction pathway. In one reaction, we have not used the catalyst. In that case, activated complex or transition state appears at maximum level. When we use a catalyst, this shown by dotted lines. Here the transition state get lowers, means activation energy get lowered, and here equilibrium position approaches lower. It gives product, and at the end of reaction, catalyst remains as it is. Here in this reaction, catalyst speed up the reaction. It accelerates the rate of reaction. Theories of catalysis. First one is intermediate compound theory of catalysis, and second is adsorption theory of catalysis. According to intermediate compound formation theory, the catalyst react with one of the reactant to give an intermediate, which reacts with another reactant to yield product, and the catalyst as follows. Suppose reactant A in presence of catalyst gives intermediate. And this intermediate react with reactant B, it gives product with the liberation of catalyst. Here intermediate acts as a catalyst. Here is the example. Twice SO2 plus O2 in presence of NO, it gives twice SO3, which proceeds in this way. Twice NO plus O2, it gives twice NO2. This twice NO2 plus SO2 in the second state get converts into SO3 plus NO. Second one is adsorption theory of catalysis. The heterogeneous catalysis example is gaseous reaction on a solid surface is explained by this theory as follows. Both reactants are in gaseous phase, whereas catalyst is in solid state or liquid state. These react and it gives C plus D in gaseous state. Following are the 4 steps involved in the heterogeneous catalysis. Diffusion of reactant at the surface of the catalyst, adsorption of reactant at the surface, reaction of reactant at the surface, desorption of product from the surface. These are the types of catalysis: homogeneous catalysis, heterogeneous catalysis, positive catalysis, negative catalysis, acid catalysis, base catalysis, autocatalysis, and enzyme catalysis. First one is heterogeneous catalysis. In this, catalyst with different phase as the reactant. Means reactant and catalyst are in different phase. Usually, solid state example is decomposition of H2O2 with MnO2 as a catalyst. Another example is hydrogenation of ethane, whereas nickel act as a catalyst. In heterogeneous catalyst, in this reaction, the catalyst provides an active reaction surface for the reactant, in which reaction occurs with a lower activation energy. Are usually transition metals such as PT, PD, V2O5 and Ni. Second one is homogeneous catalyst. This is an catalyst with the same phase as the reactant. Means here catalyst and reactant are in the same phase. Gaseous, gaseous, solid, solid, or liquid, liquid. These are usually in aqueous state. Example is oxidation of ion by S2O3 with Fe3 ions as catalyst. Third one is autocatalysis. The product in the reaction with the catalyst of the reaction. In this type, during the reaction, the product formed during reaction acts as a catalyst and it accelerates the rate of reaction. This reaction is called as autocatalysis. And the product is called as autocatalyst. For example, twice MnO4 plus 16H plus 5C2O4. It gives twice Mn plus 8H2O plus 10CO2. In this reaction, twice Mn acts as a catalyst during the reaction. By the graph, we can show, first graph is showing that the rate of reaction is low. And the second graph is showing that as soon as the Mn forms, the rate of reaction gets increased. Next one is positive catalysis. The catalyst which increase the rate of a chemical reaction is called as positive catalyst, and the phenomenon is known as positive catalysis. Example is twice KClO3 in presence of MnO2, it gives twice KCl plus 3O2. S2O2 in presence of platinum as catalyst, it gives S2O plus O. The next one is negative catalysis. The catalyst which decrease the rate of reaction is called as negative catalyst, and the phenomenon is called negative catalysis. For example, S2O2 decomposes as S2O plus O in presence of acid analyte. Here, acid analyte decreases the rate of decomposition of S2O2. Therefore, it acts as a negative catalysis. Next one is acid catalysis. A acid catalyst increases the rate of reaction by providing proton to the reaction. This is an example shown by the mechanism. In this reaction, OH ions, that is protons, are provided and the rate of reactions is increased. Base catalysis. A base catalyst increases the rate of reaction by removing a proton from the reaction. This is specific base catalyzed dehydration. Next one is enzyme catalysis. Enzyme catalysis is the increase the rate of reaction or process by biological molecules. Enzymes are biological catalysts. Enzymes control chemical reaction that take place in the cytoplasm. Catalase is an example of an enzyme made by living cell. These are some properties of enzymes. Enzymes speed up reactions. Enzymes are made up of proteins. They are specific in nature, not used up during reaction. They require optimum condition at which they occur best. At high temperature, they become denatured. Here are some industrial application of catalyst. Uses of catalyst in chemical industries. In industries, manufacturing cost and yield of product, these are the major issues. Because during manufacturing, we require high pressure, high temperature, high concentration. By using catalyst, we reduce this in some way, and we can reduce the cost of manufacturing, and we can increase the yield of product. Thank you.